So we are live. Good morning, everyone. Good afternoon for those of you in different parts of the world, or even good evening. This is this really a Magnitude Live? I guess an extension of Magnitude Live, our show. This is the LCATS and WEX Foundation. And oh my goodness, this pandemic's kind of causing really kind of havoc with us doing full fun stuff with students around the world, but it hasn't prohibited this group from preparing an around the world balloon launch. And this is my really kind of messy garage, but I'm going to share it with the world anyway. There's your balloon. Looks like a glorified plastic bag. Plastic bag. And on the end of it is some electronics. I guess I should grab this real quick. And these electronics are designed by a NASA engineer, Bill Brown. Oops. Oh no, I got something caught. One second. That's all I need to do is rip something right now, right? Here's your electronics. It's called Sky Tracker, and it has solar panels. Put my screen back up here. And a APRS radio, automated packet reporting service radio, that uses amateur radio band to send data from this Sky Tracker to any ground station that can pick it up. And it's pretty fascinating. But these students will tell us more about our forecasted flight today, where we think it's going to go, learn a little bit about the atmosphere and the weather around our Earth, and maybe some other cool facts as well. I'll put this off to the side for now so I don't damage anything. And why don't we start with talking about the weather, not the weather, the atmosphere. Why don't you share with us first to introduce your first name, and then and maybe tell us a little bit about your studies there with LCATS, some other activities you guys have been working on. I think you're working on rockets too. And then let's talk about the layers of the atmosphere.
So my name is Advika, and for now, we've been making rockets, and I researched yesterday about the atmosphere. And so our balloon is going to travel approximately 13,700 meters, and this is roughly equal to 8.5 miles. So this means our balloon will go anywhere between the top of the troposphere layer and the start of the stratosphere. At this height, the atmospheric pressure or standard pressure will be about 0.15 atm. So the standard pressure at sea level is 1 atm. So as you go higher, the atmospheric pressure gets less and the atmosphere is thinner. Also, the kilopascals at 13,700 meters is about 14.7. So 101.325 kilopascals equals 1 atm or sea level. So it also shows that the atmospheric pressure is getting lower at the higher altitude. And that total pressure is 2.14 psia. This means that the gauge plus the atmospheric pressure equals that number. And then this will affect our balloon flight because the higher the balloon rises, the more it will expand. And if the balloon reaches too high, that low atmospheric pressure could cause it to pop.
Mm, that's an interesting fact. And so what we wanted to do is not overfill our balloon. In fact, it was recommended from the engineers that build the balloon to give us 8 grams of positive lift. That's not a lot of weight, but our payload itself, that little Sky Tracker, only weighs about 13 grams all by itself, a little bit over 13 grams. And so with that 8 grams positive lift, it should take us around that 13,700 meters. But after talking to Bill Brown, the Sky Tracker's inventor, late yesterday, there was another balloon attempt. This team took 9 attempts before they were able to finally get their first around the world attempt. So they think we have like a 10% chance, or that's what they suggested when they were talking about it. But what they did do on their successful attempt is they reduced the lifting capacity, so put less helium in the balloon to accommodate for that expansion of the gases and the lower pressure, to only about 6.75 is what I put in this one. And so our lift is a little lower. So our altitude might be a little lower than our projection after we finally get a loft in a few hours from now, we might want to rerun calculations. But before we do that, in order to launch anything, you guys probably watched the SpaceX rocket go up the other day, sending American astronauts and an American rocket on American soil back to space, which is pretty awesome since it's been a while since we've done that, almost a decade. The weather inhibited that launch. And so unless we've got really great weather, then we're going to probably not do that. So I've got a weather report then, right?
Yes, you do. Can I share my screen quick? Some screenshots. Okay.
And while we've been chatting here, I just want to introduce our colleague, Liam Kennedy, who's in Southern California. He's closer to San Antonio than we are. And Liam, you probably saw my balloon off the coast of... I'll see you in Europe, man. So just a quick sidetrack. Liam and I started a balloon race with 2 other groups on Monday. And after the first day, we totally were off the map. And Liam woke up and he technically won the race. And then that was great. But the next day here, we're both on the Eastern Seaboard. And I won't steal everyone's thunder here, but that's maybe a different show. But now we're right on the edge of the East Coast. And it looks like we're about to hit over the pond. Kind of fun. So this will be a fun next leg.
Yeah, yours went out into over the ocean. So you're already over the ocean.
Oh my goodness.
The Atlantic Ocean. So well done. That was my fictional idea. I made this story to everyone. I said, I am sure everyone's balloon that has disappeared has gone up into the way north of Canada.
Yeah, well, hopefully we'll see Joanne's and Trevor's and Steve's.
That's so cool. Anyway,
weather.
Back to the regular program.
Yeah, weather. So what do you got, Yusuf? Go ahead and share your screen.
Let me share my screen and figure out how to use this again. Sorry about that. So I got some photos from basically yesterday that outline the weather. Let me go to the basic one. That's not it, is it? That's English. There you go. So basically it's just the weather forecast for the next 10 days. I did this late at night yesterday because I don't know, why not? And basically it just says, as you can see, the rain, it was going to be pretty rainy after Wednesday, like on Friday, Saturday, and Sunday, about there. So that was pretty much a no-go, and the wind was higher throughout basically the rest of the week than now, which is on Wednesday, right about there.
No, so we're actually, it looks like we're like the best time and day of the week to put this thing up.
Yeah.
Yeah, even next Wednesday, it looks like it's going to be stronger. Wow.
This is just the forecast for hourly.
And so we're going to try to, oh, there you go. Look at, that's a good one. 4 mile an hour winds. Okay. No rain. 60%. What's that? 60% line. Green.
Green is humidity.
Oh, okay. So there's a good amount of moisture in the air. It's not really dry. That's okay. And 71 degrees. Cool. And is that the dew point, I guess, at 56 degrees?
Yeah, the dew point's 56.
And, yeah, like almost no clouds in the sky at all. When I get outside, it's probably going to be all blue. Well, that's wonderful.
What about the wind speed?
The wind speed's 4 miles per hour, about like east.
And it looks like our wind direction's going westerly winds, so we're heading almost due east. Great. All right. So I guess we're go for launch as far as weather, right?
Yeah, basically.
All right, fantastic. And our payload's ready to go here. How about some projections? Where do we think this thing's going to go? Now, I understand, said that you used the NOAA tool, National Oceanographic and Atmospheric Administration's tool. Do you want to walk us through that?
Yeah. Can I share my screen?
Absolutely.
Okay. Okay, so we can use this website right here, thanks to NOAA, and it can give us insight on where and how far our balloon will go. So over here, we need to input our starting locations. So we will launch from 37.8653 degrees north. And 122.3111 degrees west.
Okay.
And then in meteorology,
Mhm.
we'll select 192-hour forecast with 3-hour adaptations, and we're going to measure our global pressure. Yeah,
Okay.
and then I'm going to click next. And over here, it shows the forecast cycle, and I want it to be the most recent time. So it's the top one right here.
Great.
So this next page shows me my parameters, and we do have to change a few things over here. So our start time is in universal time, and it looks like the year, month, and day are right, but our hour will be 15.
Okay.
And then our height will be 13,700 meters. And we want it to be average mean sea level.
Perfect. Wow, look at that. It looks
And
like
then
you
we
got this
do
figured
want
out.
to track the rain.
Mhm.
So I'm going to select this.
Mhm.
And then I'm going to request the trajectory. It's going to take a little while to load.
Doing little calculations here.
Yeah.
Okay. Now, will you run this again when it's in aloft, when it's in the air?
Yeah.
Okay.
And then this is what it's expected to look like. So it goes down southwest and then up north through New Jersey right here. Yeah.
So
then,
that's interesting. If we look just over, that's the Atlantic there, but it's doing this big loop in the center Atlantic for some reason.
Yeah.
What's the coast there? What's the countries? Does it look like it's on the edge of that map in the upper right hand corner? Is that
Spain?
Mm-hmm.
I think. Yeah.
Oh, that's the Mediterranean, Portugal and Spain.
Yeah.
And then it's North Africa. Wow. Okay. So we're getting close. That might change, probably will change. And there's triangles on this line that's traveling across out to the Pacific and over the Midwest there. There are large triangles and smaller triangles. What are those?
Those show the time.
Okay.
And then it helps us track how much, if there's any rainfall over here.
Okay. Oh, yeah. Let's look at that. Oh, what are we looking at here?
Around the 7th,
Uh-huh.
Somewhere in the East Coast, we hit a lot of rain. Around 6 a.m. Universal Time, I think.
Wow, that's a lot of rain.
Yeah.
Okay, so we were looking at practicing on the format earlier, and we thought it was a little earlier in the States here, but it looks like it's going to be on the East Coast. We should probably do a weather forecast then. Yusuf, you want to help us there? And first of all, everyone, can we confirm that looks like that's the right time on the map?
It looks to be like centralish Ohio, from what I can see, and yeah, it's like in the 7th.
Yeah, let's see. If we count the large triangles, each large triangle represents UTC midnight. Oops. There we go.
Yeah.
And so the first triangle in about 7 hours or so would be midnight. And then a day from then, we're back in California. So that would be the, it's the 4th. The 5th would take us right around Wisconsin. The 6th, takes us to New York. Is the 7th actually over the ocean? Is that right?
Yep.
Maybe, yeah.
Yeah.
Okay. And so how do you get a forecast over there, right? That might be kind of tough. And maybe that's why we see that dynamic change in the flight path. That's really weird. A hook it takes, right? Like it just hits a wall and suddenly wants to go around it or something. I wonder, do you guys remember earth.nullschool.net?
Mm-hmm.
Why don't we go look at that and see if we can visually see something there? That's really fascinating. That's a little different than what we were thinking about the other day.
Should I stop sharing my screen?
You could, or you could just jump to earth.nullschool, or I can, whichever.
Okay.
I'll let you drive. All right, and let's try to find that same part on the Earth where it looked like that big weather change is going to happen. And if you recall, if you select the Earth tab, you can move forward in time. Up right now, we're on the right there. So that'll take us to the third. The next would be the fourth. And oh, you can also switch it to UTC at the top there. I don't know if you see that.
Oh yeah.
Yeah, just there you go. And so that's the fifth, and that was the seventh or the sixth. You guys?
The seventh.
Okay, so can we get it to the seventh? Oh, is that like a tropical storm that's moving? Oh yeah, look at that.
Wow.
Now that's surface level, right? So why don't we get our hectopascals, or I think someone gave us a report in kilopascals. So that's just 10 times more, but than the hectopascals we see here. They're 10 times less. So was that like 25? What was the kilopascals again?
It was 14.7.
Oh, okay. So that's pretty low. So that would be halfway between 70 and 250, thereabouts. Let's try the 70.
Okay.
That's hectopascals. That would be like 7 kilopascals. So not a lot happening up there. So drop it down to 250. Yeah. So we're going to get more of that rather than the other one. And this is the 7th, and this is midnight UTC. Wow. Can we rotate that down a little north and to the east? Looking like get a little bit of Europe in this picture. There we go. All right. Well, if we go that far, we would have traveled across the U.S. I guess what we could do, if you wanted to, you could actually stand down on this mission and scrub. But, you know, the first few days looks pretty good, and weather does change. You can also just let it go aloft and see what happens. You know, technically, I would say we probably want to do more research on something like this. I'm feeling pretty good about the first few days, but ultimately you guys, your team here with LCATS will be the arbiters of whether we go, no go. We're go for weather here local. Our balloon's filled up and ready to fly. Our payload's operational. And so should we give it a go?
Yes.
All right, so we're going to give it a go anyway. Right now we're at 7:18. We can just hold it open for a general discussion and maybe prognosticate without knowing too far in advance where it might go. And I can turn the helm over to Tony, our co-founder at Magnitude, and Liam Kennedy, our esteemed pilot navigator, who won yesterday's around the world balloon race, or at least phase 1, right? And I'll let you guys talk a little bit about high altitude ballooning, a little bit about amateur radio as I suit up and get out the door here. Also got to get my son and his girlfriend ready. They're going to help me get this thing aloft. So keep on chatting here and I'll get things ready.
Okay. Hey, Liam, you want to talk about the ham radio?
Sure. Yeah. Let me.
How one can get the ham radio license? What's the process of getting one?
Sure. You know what? I'm just going to go grab my ham radio, which is just out of reach. So I shall be right back. And yeah, it looks like I'm in space right now, doesn't it? That is recorded video from the space station. Anyway,
Yeah,
I'll be right back.
Liam is the inventor of ISS above. It is a Raspberry Pi where you can connect that to your normal monitor or TV, and you can view.
All right, so I'm back.
Okay, you can view the Earth from International Space Station live. Is that cool? Do you have one at home? No.
Oh, sorry, was that to me?
Yeah, no, I was asking the students.
All right. Yeah. So anyone, hands up, who is ham radio certified, who has a license here? I do. Anyone else? I just want to let you know, everyone's hand can be up right now because you can have your own ham radio license, and all it takes is passing a test that you can do. Now they may, yeah, I'm sure that they allow you to do it online now. But okay, this is my ham radio, my little handheld ham radio. And out of interest, this particular radio, you can get really, really inexpensive ones. This is a little bit more than the really inexpensive ones. The inexpensive ones only cost about $30 off Amazon. This one is a little bit more expensive because this can independently receive the data, the telemetry from the type of balloon, the actual system that you're launching today. So this has a little digital receiver and transmitter that operates with APRS, which is the packet radio system. But anyway, I probably digress because what Ted asked me to talk about was, what it takes to get your ham radio license. And just so as you know, the end result of getting your ham radio license is that you get your particular call sign, and you can choose your own, but by default, you would get a pre-assigned one just off a list that that is provided for you. My call sign is Kilo November 6 Echo Quebec Uniform, which actually translates to KK6 EQU. And so, and you'll notice that Ted's is, what is it? Anyone remember what Ted's call sign is? KK6 UUQ? I think that's his anyway. But what does it take to get it? It takes completing a set of questions and getting above a certain grade level. Now, I was, the reason I got my license really was actually because of this thing. So Ted mentioned the fact that that I do things with the International Space Station. Obviously, so does Magnitude.io. But did you know that with with a ham radio license, you can actually communicate with astronauts on the International Space Station? So this is where it is right now. It's going over South America, just gone over Chile, or maybe just Peru over there, heading into Brazil. And it's possible for you to schedule a school connection with an astronaut on the space station via ham radio. And I just happen to have done
Wait, we can hear Liam. Ted, I think your audio.
All right, I'm back again.
Okay.
Yes. So what I was talking about is that I got my ham radio license really to support the school contacts with the space station through a program called ARIS, Amateur Radio on the ISS. And that's where you can literally have a conversation with an astronaut as the space station is passing by your school. And although things are a little bit different now during the pandemic, ARIS is still running them. They allow all the students to actually be remote, and they dial in to a central location, and that's run by a ham radio operator.
That's absolutely amazes me that they are able to take that.
Yeah. So, but I just want to let you know, every student who's on here, I bet you will find a way to get the exam for free. It is only like between $5 and $15 to get the exam. Then you can have a $30 ham radio and speak to one another via, via a ham radio device like this. And very cool thing to have, and lots more that you can be doing with it once you're in the ham radio community world. And so I definitely recommend you check it out. I think the website to go to is ARRL. That's the American Radio Repeater League, or ARRL.net is the website to go to. All of the information on, you can actually do all of the practice tests there, practice questions. That's how I did it. I swatted up. I was the worst kind of student. I just decided to do it. So over a few days, I just went through the exam online and then showed up at an in-person exam situation. And there we go. So yeah.
Liam, while you have the license, will you be able to put a transmitter on top of your house?
Yes. So once you're licensed, so without the license, you are allowed to receive to listen in on any amateur radio transmission. However, in order to transmit, that's why you have to get your license. So once you do that, now I just have this handheld. I have not gone to the extent of having any external antennas, but that would be highly useful if I was going to be doing more communications out there. Currently, mostly what I do is so. You'll recall that the sky tracker that is on the bottom of your balloon, it actually has an APRS transmitter in it. That's how the data, the telemetry is sent down to the ground. Well, would you believe it? The space station actually has its own transmitter. And it transmits APRS data that amateurs can send to it. So just let me go back to that again on here. So this is the orbit of the station right now. So imagine the space station was going to be passing by you. You can actually, with the right transmission, with the right antenna, you can transmit a signal up to the space station. And because the space station is passing really quite fast above you, that's 5 miles per second fast. Generally, you have to have an antenna that is tracking the space station when it's passing by, or like me, I don't have that kind of expensive equipment available. So what I have is I just go outside and I point my antenna at the space station when it's passing by. It does that 5 to 8 times every day. And when it passes by at nighttime and it's visible, which it will be 3 or 4 times every month in the evening and 3 or 4 times every month in the morning, you can literally point your antenna manually at the space station, and you can beam your own message via something like this, or you can even connect it to your computer and send a message. And it's like a text message, but just the coolness factor is that your message goes up to the space station and back down to a ground repeater station, and then gets onto a website where you can see your message that's been sent. So anyway, I hope everyone here is going to consider getting your ham radio license.
I think so, right?
Yeah, most astronauts are ham radio licensed, and that's because that actually allows astronauts to conduct amateur radio communications from the space station to the ground using the equipment that's on the space station. So It's a good thing if you want to apply to be an astronaut, if you can say you are ham radio certified. It's one of the check boxes you'll find that has you get out ahead of the rest of the pack. So that's just my little tip for becoming an astronaut.
Right. There's something a little pedestrian, but very valuable about having your license as well, of course.
Mm-hmm.
When in an emergency, the amateur radio operators usually have generators and good repeater antennas. And when the cell towers go down and when the plain old telephone service goes down, your amateur radio operators fire up and they're able to direct response teams and fire, flood, earthquake. And you see that happening really around the world. And so you think about yourself as a citizen first responder from a communications perspective. And if you ever worked on a team, even on like a school project, you know how important communication is, right? So you imagine in a disaster, how important it is to begin putting those connections back together. So people know where supplies are needed or where, help is needed in an area. Okay, so we're pulling right up now. I'm gonna need to put on my my mask, and I've got some help here today. My son and his girlfriend, Ben and Hannah, are joining me on our little hike up the hill and let this thing go. So give me just a minute. Back to you, Leah.
All right, wonderful. So this is, I think, Ted, this is your usual spot that you're launching from.
Copy that.
Wonderful, wonderful. A really great location. And this particular balloon, because it's the version that can go around the world, is much, I would say, more cumbersome to actually work with than the smaller 1 meter Mylar balloons that I've been using. So that's why having extra helping hands, I think, is a very important, critical part of this. And so we'll see what that looks like in just a second. I've just got to let you know, I've only launched 2 of these Pico HAB balloons with the Sky Tracker device on them. My first launch was a miserable failure. But the good thing in the engineering sense, when you have a miserable failure, you get an opportunity to investigate what went wrong. So in my side, mostly what I believe went wrong in mine was I misfilled the balloon. I actually managed to get more regular air inside the balloon than I should have done. And the end result was it was a much lower altitude than planned. And then it eventually burst, and that was because it had too much regular air in it. So when it rose up, it likely expanded way more than the capacity of the little Mylar balloon could handle, and it just burst. So it only lasted 1 day. Now, Ted's an expert in this stuff. Ted and Tony's an expert in this stuff.
No, it's more like Ted.
More like Ted. There you go.
Well,
this is beautiful.
What's the call sign number today?
9, I think I saw it. It was 9. Yeah.
Okay.
So yeah. So you can see I'm sure, before I joined, I'm sure Ted's gone through the actual Sky Tracker hardware that's underneath there. It really does look like a miniature satellite. I love the fact how it really does have the components of many satellites right in there. It's got the solar panel. It's got a little miniature battery type thing. It's really just a capacitor, but it allows the solar panel to charge up this capacitor and then powers the rest of the components on there. And have any of you, the students here, have you ever done anything with Arduino programming at all? It's a little tiny microcontroller type thing. That's really what is on there. Yes, hi there, Yusuf. You've done that. Yeah, so really it is nothing more than a very custom version of an Arduino that's been put onto a miniature PCB. All right, so it looks like Ted is really getting ready there to launch. yes, you can see there's quite a breeze. Quite a breeze there. And what was the weather forecast was today? Was it 4 miles per hour or something? Was it Yusuf? Were you showing
Yeah.
Yeah.
It was about 4 miles per hour, yeah.
Mm-hmm.
And we even looked at the time of day as well.
Yeah, let's mark it.
Yeah, I loved your presentations, by the way, just the detail of everything that you shared there, and especially the models. I guess, yeah, I want to, because it really did look like it was going to head, right out into the Pacific and then turn around. I'm curious what direction that wind is in at the ground level, because ground level winds can be very different to winds just even a few thousand feet higher up. So, because certainly at times when we've launched from here, Ted's balloon has gone in a very odd direction based around the NOAA model, but it just took it to go up a little bit higher, and then it really got into the NOAA model way of directions and things like that. So there we go. Do you know what Ted's doing right now, Tony? I can't quite see it.
I'm not sure.
Yeah.
So I had a weight baggie on here just to keep it down.
Oh,
and,
yes.
Got all caught up. So, unfortunately, it looks like I got a big tangle here.
Ah, there you go. Oh, that's a beautiful view there.
Yeah, why don't we're gonna get a nice view of the day here. Very light wind.
Oh, it is light wind. Looks like it's going sideways there.
I watched earlier that the solar panels can take a lot of that they're pretty robust, and so that if something happens, well, if they land, or they won't break, and or they bump into something.
Yeah, they're really not like the kind of solar panels that you'd expect in many cases where they're very rigid. These ones are definitely more pliable than those. So I think that definitely does help. And yeah, I'm just trying to think about anything else about that. But yeah, it obviously survives some pretty extreme weather as well.
What I'm going to do, Liam, and everyone there, LCATS team, I'm going to take this painter's tape off, and we're going to expand this thing to its full height. Lana, you want to hang on that?
Yeah, this is where it would have been so much easier had it been possible for all the students to be directly here doing this stuff.
Yeah,
I know that that's one of the things I discovered when I was just filling the balloon, is I really did need an extra pair of hands. Luckily, my wife was around to help with that. So, you know, I think we really did a good job of filling the balloon this time. And on my launch that I did on Monday, that's now on the East Coast, heading out across to Europe. Although my one was the lowest of all of them, because I was using helium balloon that I purchased from Walmart, which is only 80% pure. The helium that is going in this balloon, I believe, is 100% pure, which you buy from a commercial helium provider. And those are the sorts of things that are used in industry. By a lot of helium is used in the aerospace.
Yeah.
Yeah.
All right, I think we're ready to go here, guys.
Oh, cool.
All right, so that's our big, super fancy plastic bag, aka very expensive, high-pressure weather balloon. And weather looks great. You probably saw a view. Golden Gate Bridge has got a little fog in it. Light breeze. Really nice day today. We're gonna get this up in the ground. How about a countdown, everybody?
Oh yeah.
10.
Say Ted, just before you do that, what direction is the wind going in at the ground level there?
So we're westerly, so we're heading east. And
All right.
yeah, and it's fairly light wind right across the in Berkeley. There, you can see some steam coming up from a factory. So it's not really blowing all over, and there's still a little fog here that's just burning up.
It's beautiful. Yeah, so I want to point out the NOAA model has it going west across the Pacific a bit, right? Or southwest.
Yeah, probably go up and then cut back over.
Yeah, but I just love that differential between ground level air airflow versus higher level.
All right, we ready to go?
We got to count down, right?
10,
9,
8,
8,
7, 6, 5, 4, 3, 2, 1.
Go. Oh, look at that, dragging along the ground. Only for a second. Oh yeah, so yeah, we've all got to be tracking this now, right?
Yeah, it's going to take a few minutes, but keep our eye on it for now. I don't know if you can zoom in a little bit there or not.
All right, I'm tapping it in. APRS.FI.
This is number 9.
KK6 UUQ -9. And then someone's got to shout out. Was it used previously? Oh yeah, there was a prior launch in November of last year.
Yeah,
so
we're running into those repeats now.
Yeah, so if you see that, don't worry about it. As soon as it really shows the most recent data from it, but as soon as it gets a transmission from the current one, it will switch to that one. So, but there you go. That's the previous one.
There you go.
And the last ping from that was, it was at 26,000 feet over, where was that? What? That was, it was over in Bulgaria?
Yeah.
What? I love that. Sort of it's a good omen for today's round the world one, that
there you go.
It's sister, maybe it's bigger sister version because it's older. Bigger older sister.
Actually, might have been older sister, but it would have been a little balloon, right?
Oh, it would have been just the regular Mylar balloon.
That's right.
Oh, I got it. That's why it's 26,000 feet. All right.
I'm gonna park over there. So there you go, guys. We're up and aloft, and I'm just making my way back to the car. And as soon as we get that signal lock, you can start tracking it. And what you want to do, wait until it gets, I don't know, a few thousand meters in the air, and then try to look at the average ascent rate. And we should be around a meter per second, maybe a little bit more, but not much more than 1.2 or 1.3 meters per second. Because we did put less helium than we did on our last attempt. It's recommended that we do 8 grams lift. We went to 6.75 on this. All right, so I'm gonna demask myself so you can hear me a little better.
And just to let you know, you don't necessarily have to keep refreshing the page, because the APRS.FI page should automatically refresh the data.
Oh my! I pound on the refresh button all the time. It's like, but you know how you just have to keep on hitting the button?
Yeah, I know. I was telling you not to hit refresh, and what was I doing? Yes. I was also hitting refresh too. So, and if Ted has bought his radio, there it is. Yes, and I didn't have to hit refresh. So anyone who's watching, the first ping has come from it. Has anyone else seen that?
Yep, I'm seeing it.
Very
Can you
cool.
share your screen?
Yeah.
I shared the link in the chat.
Okay, there it is.
Yeah.
Go ahead and share the screen there.
Do you want me to share it?
Yeah, go for it.
Okay. All right, so I'm just going to share my screen here. So yeah, so does anyone know how frequently the data is transmitted from our Sky Tracker underneath there? Does anyone know how frequently it is? So it's actually every 2 minutes. So at the moment, we just received the first data packet from it, and that was at 7:44 a.m. So the next one will be in just over a minute. And so yeah, so and what Ted was saying is don't necessarily rely upon the ascent rate initially, because and that's really the ground effect, because the ground layer winds can be messing with the vertical ascent rate. So we really have to let it get a little bit higher before we can really get a reliable difference in altitude between each 2 minute data packet. So we should be seeing another one come up soon. And again, you don't need to refresh. This thing will automatically just appear there. Let me see if I can show the repeater information. There we go. We got the next one.
Yep.
Yeah. So the next one, the previous one, 656 feet. As I say, and 2 minutes it went 400 feet.
It's going north, Liam?
Yeah, it does. It looks like it's going north-northwest. Yeah, and
ready to do its big loop.
Yeah, and we're expecting it will once it gets higher, it'll be heading out west or even southwest. I'm trying to remember what the model looked like.
Southwest down. Baja. Before it takes off, Liam.
Yeah, let me.
Maybe one of our that code again.
So let's see what else is over here. One of the neat things to do, if you download the desktop version of Google Earth, you can get a 3D track of your balloon's path, which is a very cute thing to look at. You can just click on this Google Earth KML, or you can go into the data export tool, and it will save a file that you can then open in Google Earth Pro and see the actual visual of the track in 3D space across the Earth, which I always love to do. So what else about this? Yeah, what you typically want is it's not such a critical thing right now because it's just launched, but you see these links over here where it says show last. You want to set that to, just so that you bookmark that particular one, set them both to 7 days. So it's not going to make any difference here, but by doing that, every time you come back to this, it'll show the previous 7 days up until now. So it allows you to, see precisely what has been going on over those days. That's what I wanted to hook up. So I'm going to zoom out. You see when I'm hovering. Not quite. There you go. When I'm hovering over it, you'll see that there's a purple line that appears. And what that is doing is it is drawing a line to the ground station that was responsible for picking up the telemetry. Very annoyingly, as I zoom out, it then loses that purple line. Well, there we go. That one over there. You see that one is pointing to this one.
There you go.
So this is literally the location of an amateur radio operator's ground station that they have configured to be listening for those kinds of data packets. So and they're not really just the APRS data packet system is not just for balloons. It can be used as a legitimate way to track anything you want to track. So many ham radio operators may have a transmitter in their vehicle or just on their handheld. With my handheld, you can press a button and it sends your location somewhere. It's the sort of thing that if you were into doing hikes in remote areas, it is possible that you can remain in digital contact. Oh, there we go. It's just moved. Look at that. It's gone in a completely different direction.
Oh, wow.
It's turned completely around. That's awesome. Now it's, yeah, so now it's heading south, really, southeast.
All
Very
right.
cool.
We don't need to take up the whole hour here, but you are aloft. You've got your tracking information. Our weather predictions and forecasts look solid. I think we're going to have a nice ride across the U.S. Do rerun your predictions at the end of the day when you get your last signal. Use that as your starting launch point. Make sure you have the right date, time, and the correct altitude, and then run a new forecast and look at what it's going to look like and see how close it is to the previous day, and continue doing that. And then I don't know if you guys got plans to have a meeting in the interim, during the flight thing, maybe as we get to the East Coast. So the 8th or something, the 7th, I think that was over the ocean already. So maybe the 5th or the 15th. I might get a drop here in a second. Thanks, guys.
I think we should also give a good shout out, thank you to your launch team, Ted, just for.
Oh, absolutely.
Yeah,
Hannah,
we know it wouldn't have been half so easy if it wasn't for the fact you had some extra hands there.
I know, for sure. All right, back here at the office. I'm gonna end this.
Oh, there you go. Now at 2,000 feet. Although I think we were working off metric. So you can switch the preferences over to metric as well, which is just over here. And obviously, me being the guy from UK, which is in the metric system now, I guess I should be in that mode by default.
Yeah, right. What's up with that, Liam?
I know, that's right.
An American citizen, you go to Imperial. What's up with that?
I know, that's right.
All right. So students, are there any questions? Is this exciting? You feel pretty awesome? It's just going in. Look at that. It's just a full lap.
Oh yeah, it's amazing.
What's our altitude right now? What's it look like?
It's just around 2,000 feet.
Oh wow, there you go.
And I think what I'll do,
50 meters or something like that.
Yeah. Let me just close that.
I'm sorry, more than that. Like 650 meters.
Here's the one.
Tape in my pocket. All right. So just to check in with our students here. I think I understand someone might have had left early or had a different appointment coming up. But are there any questions or comments we want to make here before we sign off on the launch here?
Well, it was exciting, that's for sure.
There you go. Well, that's the first part. I would love you to
I thought I'd share my Google Earth.
Oh, there you go. Look at that. Oh, wonderful. Yeah, it's just looping around. Golden Gate Field. And yeah, you just rotate it clockwise about 90 degrees looking east. And that's pretty much what we were looking at when we launched it. There you go. And directly.
So yeah, you launched it right over here.
A little
somewhere
closer
sort of
to
on the top of the hill
area there. Yeah, pretty much.
Oh, okay.
Yeah, right in there. Yeah.
Yeah. Yeah, there you go. That makes sense.
Mhm.
Hooked up.
That's nice. I got to remember, with extra hands, I got to remember to bring binoculars and I can watch a little bit longer.
Oh, yeah, it's a little bit harder to pick that one out, though, isn't it? Because it's not the reflective mylar balloon type, probably.
Yeah, yeah, it's just like a little,
Yep.
I don't know, a sea creature in space.
Hmm.
Awesome.
I can't remember whether this is actually going to update itself as well. I've seen information that says this is actually linking to the actual live tracking, but we'll see, I guess, if it does refresh.
Well, that'll be new. I haven't tried that before, Liam. That's pretty.
Yeah, it just said there was something here that said it is. Yeah. Yeah, I read something that said it could be live tracking, but I just wasn't ever looking out for that. But anyhow.
So why don't you unshare your screen for now, Liam, if you can, and we'll do a sign off.
I will. There you go. All right.
And well, that was really pretty awesome to get this thing up. Not the same as being there in San Antonio, but that would have been a 3-hour flight. And this one, let's hope, is one that goes for the record books here. And I would, Nicole, if we can, I don't know, I know this is the end of formal studies for the LCATS program for this year. But if these students or the other students in the group want to convene again, I'm more than happy to schedule something, as it gets across. We'll be updating our Facebook. So if you're on Facebook, just find Magnitude.io, friend us, join our channel on YouTube as well for updates for what we're doing there. We run projects on the space station, other cool stuff. And I think I might run just a little blurb, a blog post or something about the update on your balloon for sure. And it'd be ideal if you guys provided the report. So if I can, why don't we, you guys can write it individually or work on it together, but I'm going to give you an extra assignment if you're up for it. I would love a report once we get off the East Coast and we get our last transmission from the ground. And that would include your flight prediction, how long you think it's going to go aloft, and maybe things we learned about this balloon flight, where it had traveled, and some any other information you think is interesting. And if you've done some more research about getting your ham radio license, it'd be great to report that as well. Requiring you guys to do something like that, we'll encourage you any way we can. So you guys are going to get your balloon wings. I don't think we have anything like that yet, but figure out a way to recognize your diligence in sticking with this program all the way to the end, even though it's like this unusual, weird, not normal kind of program. So I feel pretty excited for you guys. Any other final thoughts or questions, ideas?
I just wanted to thank our students for being very flexible, especially during these times where everything is unpredictable. And our 3 students that we have here today, they kind of, yesterday I contacted them and said, I need you. And they didn't have any hesitation of coming on board and helping us today. So I'm grateful to them.
Awesome. Well, that's fantastic. All right, guys. Well, we're aloft. I'm looking forward. I'll be tracking it all day long because my the other balloon is now going to be over the Atlantic. I won't see it for a while, so I have something I can watch for a few days. So if you have any questions, please reach out to Nicole or anyone else on the LCATS team. They can get that to me. And you can always send an email to hello@magnitude.io. It's going to get to the team. And if you have a question, we can answer it. All right, guys. We're going to sign off for now. And this will be on our YouTube site in a few minutes, so you can see it and what we recorded. And feel free, and please share it with your friends and colleagues. All the students that didn't attend the launch, they might be watching on YouTube. You guys, it's great to be with you this season. And let's hope next year we're live in San Antonio. Okay. Until then, Magnitude Live and Magnitude.io is going to sign off.
Bye.
Hi, guys.
Thank you, Liam.
Bye, everyone. Thanks for inviting me on.
Always.
Thanks, Liam.
All right. Cheers.
All right.